Assalamualaikum dan selamat sejahtera. We are from group 11 and this is our group members. The first one is Lisley, Lana, Anak, Ebie, Dareetia, Anak, Nurul, Izzah, Binti Razak, and Muhammad Zamir bin Iberahim. Below everyone's name is the list of tasks for each member.
Objectives.
Our objective of this video are: number one is assess students' knowledge in the programmable logic control subject in order to be able to give a good and accurate description. Number two, analyze PLC programming using various process description in order to operate an automation system for a variety of applications. Number three, be able to use a CIS programmer software to program, testing and troubleshooting the error in PLC programming and engineering problems. And lastly is give an opinion on the most efficient ways of learning on difficult topics that picked by a student.
Safety and precaution. Week 1.
Alright, in the first week of this second semester, during the PLC class, we are having an industrial talk by phase 2. So in this video, I just want to share the content and the knowledge that we got during the industrial talk. Okay, what is phase 2? What kind of company is this? For people that is related in engineering field, they already familiar with this big company, but some people, especially that is not in this engineering field, they didn't know this kind of big company like phase 2 Omron. But for engineer, they already familiar with this company. So phase 2 is big company from Germany that produce and sell and they supply pneumatic and hydraulic system for industry and for automation process. During the industrial talk, we've been explained more about pneumatic and hydraulic system. So that's all for.
Alamak, masa nila kau nak nangis.
That's all for week 1. So let's move to week 2.
Week 2.
Salam sejahtera and have a good day. My name is Dareetia Anak. Today I will talk about PLC course activities on previous semester by BND and BNE student. The course code is BND 32103 and BNE 22103. For the first activity is from BND student from semester 1 2018-2019. Their group project is programmable HMI touchscreen LED. If you want to see the video, you can click the link below. As for second activity is from BNE student for semester 2 2018 and 2019. The group assignment is wiring mentor-mentee program. Mentor is from BND student, mentee is BNE student. They are helped by Puan Rashida. And for group project, there are 6 group projects. Group 1 is automatic hand dryer. Group 2 is irrigation system. Group 3 is tool gate. Group 4 is roller coaster safety system. Group 5 is automatic shoes rack. And last group is food elevator for their group project, which is PLC application. And third activity is from BND student. Group assignment is wiring mentor-mentee program. The mentor is BNE student, mentee is BND student. They are also helped by Puan Rashida doing this program. For their group project is PLC application. There are 6 groups. For group A is smart car park system. Group B is soil distribution using conveyor belt. Group C is smart sink. Group D is multi-level parking system. Group E automatic car wash. And last group is PLC based automatic cutting machine. And the fourth activity is from BNE student, which is semester 2, 2019 and 2019 to 2020. This semester is started online learning. The group project is PLC circuit industrial application. This is timing diagram and ladder diagram for PLC based fully automated washing machine that chosen by our lecturer, Miss Maya. And activity 5 is from BND student. For semester 1, 2020, 2021, which is last semester, we are still ongoing online learning. For individual assignment, they are needed to do video for PLC connection to hardware. And group project is teaching and learning for whole semester. That's it from summary for this week.
Week 3.
At week 3, students have been provided with 2 learning material, which is Omron CP1E datasheet and second pre-lab activity in topic of familiarization with PLC Omron CP series CP1E CPU unit. Okay, firstly we go to Omron CP1E datasheet. Okay, what we have been learning in this datasheet is the model number of Omron CP1E. Okay, in this datasheet, it also has application model. The application model that Omron has for type NA is normal type, renewal S1 type, and renewal S type. Okay, after that, this datasheet also have a input output memory area. Data can be read and written to input-output memory from the ladder programs. Input-output memory consists of an area for input-output with external devices, user areas, and system areas. So, in this subject, we only use 20 input-outputs point. So, this is the info that have been given in the datasheet. And this is the output for the 20 input-output PLC Omron CP1E model. Okay, after that we go to pre-lab activity. At the end of this pre-lab, we be able to familiar with the Omron CP series CP1E CPU unit and understand the features for CP1E E20 and CP1E N20 models.
Week 4.
And I will present the week 4 summary, which is pre-lab activity. Okay, for pre-lab learning outcome is familiar with the Omron CP series CP1E CPU unit, and then we are able to understand the features of CP1E E20 SDRA and CP1E N20 DRA model. Okay, what we gain from this pre-lab activity is we are able to learn about PLC architecture, and then we are able to explain the model structure, label the internal interface for each CPU unit, and identify the different features between both models by referring to model number structure. Then we are able to state the external interface label for each CPU unit, different between both model, and different features by referring to the datasheet. And then next we are able to illustrate the system configuration for basic and application model. And last but not least, we are able to apply the step-by-step to check the input-output memory reference of CP1E CPU unit by using CX programmer and explanation of the input and output bit for 20 input and output point. First step is we open the CX programmer, then click Help menu, and then click I/O memory reference, choose CPU unit, which is CP1E. Then we will able to check the input-output memory reference. Okay, that's all for week 4 summary. Thank you.
Week 5.
We have been given a few learning material to study, which is ladder diagram, basic ladder logic instruction, basic logic function, and mnemonic code. Okay, ladder diagram. Ladder diagram commonly used to document industrial control logic system, called ladder because they resemble a ladder with two vertical bus bar power supply, left and right, which is left side is 24 volt and left side is 0 volt and right side is 0 volt, and as many rungs, horizontal lines to represent the control circuits. And this is the example of the ladder diagram. Okay, after that we go to basic ladder logic instruction. As you can see, there are several basic ladder logic instruction, which is load, load not, and not, and or not, or load and load, and the output. Okay, this is a basic logic function that have AND gate, OR gate, NOT gate, NAND gate, NOR gate, and exclusive OR gate. From 6 of logic gate, this is the one example we choose exclusive OR. So as we can see here, if you want to make a mnemonic code, we have to put a rung, step, instruction, operand, and command. So this is the answer for the question.
Week 6.
Familiarization with control instruction. Question 1. A pulse switch start button is used to start a motor, and another pulse switch stop button are both physically normally open type. So the question is A. Assign input and output address. So input is start 0.02, stop is 0.03, output is motor 100.01. So the question asks us to draw the ladder diagram for this control circuit due to normally open type, and the stop button must be normally close contact in ladder diagram. So as you can see, the stop button is normally close contact and start is normally open contact. So analyze the control system. Initial condition given positive 24 volt DC power supply, the motor will active low. If start button is pressed, the motor will on. If start button is released, the motor will off. If start and stop button is pressed, there are typo here, is pressed, the motor will off. So question 2 is modify the ladder diagram in question 1 so that the motor should continue to run even though when the start button is released. So they are using latching, normal latching. And for next question is modify the ladder diagram in question 2 using set and reset instruction. This is using set and reset instruction. For next question is modify the ladder diagram in question 2 using self-holding, which is indirect control dominant of they are same as normal latching ladder diagram. And last is modify the ladder diagram in question 2 using keep instruction. This is ladder diagram is using keep instruction.
Week 7.
I will continue with summary of PLC instruction. So first is circle of program development. There are 4. First is writing and editing. Second is compiling and linking. Third is uploading and running. And fourth is debugging. Ladder diagrams are bounded by vertical line that called busbar power supply. The busbar on the left always has the step through considered to be a voltage positive 24 VDC connected to the busbar. The busbar at the right has no defined logical state under the standard. It can therefore be considered as implicit, and not all produced implement a vertical right line in the development tool. Generally, a code in a ladder diagram is based upon the following principle. If a condition or a combination of condition is satisfied, then one or more action, event, instruction will be performed. Rung is logically unique. Rung is a logically unit of ladder program, can encompass one or more row and column. All rung are numbers starting from rung 0. So this is step number. This is condition, left side, and the right side is action.
Week 8, Week 9, Week 10.
Alright, so week 8 is a semester break. So in week 9 and week 10, we don't have much activities as we are given a group task, which is PLC design project. We are divided into some groups. So in week 10 and week 9, we're just having a discussion between our group members in order to complete the PLC design project. So it took 2 weeks to complete the project.
Week 11.
Alright, in week 11, again, we are having an industrial talk, but this time it's not like a formal industrial talk. It's just like a sharing from 2 panel, which is this 2 panel is a UTHM ex-student. So the first one is Miss Natasha Amira and the second one is Mr. Shukur Rahman. These 2 panels, Miss Amira and Mr. Shukur, they have a lot of experience working with PLC. We already know one type of PLC, which is Omron, but there are other types of PLC like Siemens, Schneider, Mitsubishi, and Edenred. Starting with Mr. Shukur, he is a PLC programmer in a company named Asmac Technology in Johor Bahru, which this company provide automation machinery for industry. PLC that usually Mr. Shukur used is Mitsubishi and Kians. To complete the customer demand, Mr. Shukur and his team will start from a piece of paper to understand the concept first and then doing some research. After that, they will move to the next stage, which is design the ladder diagram to make sure that the machine will work as what customer requests. There are 2 methods to do the program sequence, which is conventional method and shift method. Based on what Mr. Shukur said, conventional method is a bit complex compared to shift method. Okay, the next panel is Miss Natasha Amira, who has a lot of working experience as she working at 2 different companies before she further her study in masters. Miss Natasha worked as a senior system engineer and she have 2 assistant engineers that will always help her. We've been explained about SCADA, SCADA, which is stand for Supervisory Control and Data Acquisition. So SCADA is used to observe all systems in all stations from one system or screen. It also used to overview the whole plant. There is another system called DCS and usually used in oil and gas company as it have a higher reliability compared to SCADA. There are some components in SCADA which is sensor, network or PLC, SCADA and HMI.
Week 12.
We have been given a few learning material to study that consists of self-learning PLC application. So there are a few example of PLC application, which is PLC conveyor motor, semi-automatic liquid mixing application, sequential motor control, latching circuit, and interlocking motor control. In week 12, we also learning about the hardware PLC CP1E trainer kit. So this is the ladder diagram for PLC conveyor motor. After that, this is the semi-automatic liquid mixing application ladder diagram. And after that, sequential motor control. Sequential motor control is motor will run one by one. They will run sequential by 5 seconds. After that, latching circuit. This is the ladder diagram. So if we start push button, and after that, motor starter coil will energize. When we release the start push button, the motor still energized. After that, we go to interlocking motor control ladder diagram. So basically, this is the part of the interlocking system. If we push the start M1 button here, and motor 1 will energize, and if we push start button M2 and motor 2 will energize. So if we push start M3, motor 3 will not be energized because of the interlocking motor system right here. Okay, after that we go to PLC CP1E trainer kit. As you can see here, this is the picture of the trainer kit. Okay, at the top of the trainer kit is power switch, and beside the power switch is input selector. Beside the input selector is internal switch. Okay, PLC CP1E20. At the bottom of the trainer kit is output selector. And internal lamp indicator. Okay, at the center of the trainer kit is external input switch, external output, and external power source.
Week 13.
Alright, in week 13, we don't have PLC class as at night we are having a Google Meet with our lecturer to discuss about the oral test, PLC test 2, and also video project. Video summary project. Video summary project is a group project. This one that I'm recording, this is for our video summary project. And during the session, everyone are able to ask any question regarding to the oral test, PLC test 2, and also video summary project.
Week 14.
I will continue the summary of week 14. In this week 14, we are studying about timer, which is a PLC instruction measuring the amount of time elapsed following an event. Then we are studying about counter, which is a PLC instruction that either increment count up or decrement count down an integer number value when prompted by the transition of bit from 0 to 1, false to true. Okay, the last one but not least is keep instruction, which is to maintain the status bit operation based on two-state implementation execution condition. Keep operate as the relay latching relay, which is set by S and reset by R. Okay, next is we are studying about the process sequence description. Process sequence description is essential and vital for PLC programmer development, various types of process description method had been introduced, but flowchart, narrative, graph set, and motion diagram are among the favorite due to the direct translation and smooth flow of process sequence. Okay, now we proceed to example using counter timer and keep instruction. First, we need to assign an output and an input and output address for CP1E, and then we need to do the process sequence. This is the example of using simple narrative, and then this is using motion diagram, and then this is using flowchart. Okay, next, this is a normal lecture relay ladder diagram using internal relay, and then this is how we use keep. And that's all for this week. And
There are several methods used to describe the process sequence in order to operate an automation system for a variety of applications, and among them are simple narrative, sequence function chart, also known as graph set, Boolean equations, flowchart, motion diagram, displacement diagram, function block diagram, Karnaugh maps, state diagram, binary method, and Petrinet, and many more. In this video, I will explain about one of the process sequence description that have been used in Group 6 previous assignment. Group 6 project is about automatic car wash system. In this project, Group 6 are using conveyor belt to carry the vehicles. When the vehicle sense with the proximity sensor, the soapy water sprinkles start for a few seconds. The car washer process consists of assembling several items such as a detergent solution, cleaning with a water and brushes, and then finishing the job with forced air drying fans. From the statement, we can list out the input for this project is start button and sensor 1. The output is soap sprinklers, washer motor, conveyor, and dryer. Graph set is a graphical technique for writing concurrent control programs. They are also known as sequential function chart, SFC or IEC 848. So from the statement, we have collect the input and output. The input is start button and sensor 1. The output is soap sprinklers, washer motor, conveyor, and dryer. At the right side is the example of graph set that have been made by Group 6. Graph set consists of step number, input, and action of the output. At the top of the graph set is step number 0, and the input is start button, and the output is IR coil energize. Step number 1, sensor 1 detect car, and the output is the sensor detect 1 car. Step number 2, soap timer contact on, and the output is soap sprinkler stop working. Step 3, washer timer contact on, limit switch is in high condition, and the output is washer stop working. Step number 4, dryer timer contact off, and step number 5, dryer stop working.
Ladder diagram.
so I will explain about the ladder diagram. Okay, in ladder diagram is specialized schematic commonly used to the common industrial control logic system. They are called ladder diagram because they are resemble a ladder with the vertical rail supply power and many rung horizontal line as there are control circuit to represent. Okay, we choose an example automatic wash system. At rung 0, start button, push button, and internal relay to control the other rung. Internal relay can be used as input to other rung. Okay, at run 1, there are sensor 1, stop timer, and stop sprinkler. When sensor 1 detect the car, so the stop sprinkler will trigger activated. Okay, at run 2, when sensor 1 is detect the car, then the timer will start to count. Okay, at run 3, there are stop timer, washer timer, and washer motor. When stop timer is activated, then washer motor will trigger. And then at round 4, stop timer, dryer, and timer, washer timer. Okay, either soap or dryer active, the washer timer will be start to count. And then at round 5, there are washer timer, limit switch, and conveyor. When the washer timer is activated, so the conveyor will start to move, and then will it touch the limit switch, then the conveyor will stop. Okay, at round 6, so washer timer, dryer, and output is dryer. Okay, when washer is triggered, so the dryer will turn on, and then when the dryer timer is triggered, so the dryer will stop. Okay, at round 7, washer timer, dryer, and dryer timer. Okay, either washer timer or dryer activated, so the timer will start to count. Okay, this is a counter. Okay, sensor 1, when sensor 1 is active, so the counter will active and start to count. Okay, when the counter is reach the set value, so the counter will active low. Okay, when we press the reset, all this system or all the system of counter will reset. Then run 9 is end. That's all for ladder diagram. Thank you.
Troubleshoot error and work online simulator.
Okay, the normal condition that always student do is overlapping run. So I'm going to demo the normal error student do is load 0.01 0.00 for A. I'm going step as A. Then connect with output 100.00 and choose pick as L2. So I want a parallel connection to A. So load node 0.01 stand for B. One parallel connection to A. So I'm going. Some student usually then not go to next run. They continue at below of at run 0, for example. So load 0.02 for C, then load 0.03 for B, then output 100.01 for L3. Okay. We will
This is
press
how to active the work online simulator.
this one. Enable to download program. Error found during compilation. Why? Because this is we call overlapping run. So as you can see at compiler this below, errors at run 0 there is overlapping run. So we're going to troubleshoot this error, and we're going to move this ladder diagram to run 1. So I'm going to delete. No, just later we're going to delete. C in lot D and output 100.01 L3. Because there are duplicate output at the run 0 and 1, so it's okay, we just ignore it. So I'm going to delete this one first. As you can see, there is no red line at this bus bar at positive 24 volt DC. We're going to compile, simulate, or we're using work online simulator. So there is no error and no warning. So that's all from me.
The most difficult topic.
Mnemonic coders, the most difficult topic.
Actually, all of the topics in PLC is simple and fun if you really understand the concept of that particular topic. But for me, mnemonic code can be a bit confusing and sometimes tricky. So I'm gonna explain to you about the mnemonic code as the most difficult topic in PLC. Okay, first of all, we must understand this diagram. The first diagram is normally open contact, which known as load. It is the initial instruction for every rung or line. The second one is normally close contact, which known as load not. It is the initial instruction for every rung or line, same like the normally open contact. The third one is end connection, as it is in the series contact connection. Next is end not. It is the instruction for series contact connection with the second contact is normally close. And the last one is OR. It is the instruction for two contacts parallel connection. So this load, load not, end not, and lastly OR is the instruction for the mnemonic code.
Example 1.
Okay, so the answer must be written as shown in the table. It have rung, step, instruction, operand, and command. So let me show you how did I get the answer.
Wow, amazing.
Alright, this is the first example. As you can see, this ladder diagram consists of one rung only. That means it is rung 0. Okay, the step is start from 0. This one is step 0 and step 1. This is step 2. The connection is step 2 and the output is step 3. The diagram must be read from left to right and from up to down. Next is the table of the answer. So the table must have rung, step number, instruction, operand, and command. Start with rung 0 and then step. So step 0, instruction for the normally open contact, it is load, and the operand is 0.00, command PB. Okay, then first step is still normally open contact but in OR connection, which is parallel, moving downward, so it is OR as the instruction. We must have to complete this first block first before moving to the right. Okay, so the operand is 0.02 and the current is PB2. Okay, moving to the right, which is step number 2. Step number 2 is between PB and SB. It is in series connection, so it must known as N. And between normally open and normally close contact, so the instruction should be N not. Alright, because of the normally close contact, so the operand is 0.01 and command is SB. So the last one is output. Step number 3, instruction is out, operand is 100.00 and command is left. Settle for example 1, moving to the next example.
Example 2.
Alright, this is example number 2. First, still have one rung. That means this is rung 0. So rung 0. And let's label the step first. Okay, this is 0 step, first step, second step. This one is third step, and output as 4 step. Right. So step 0, the instruction is load. Since this is normally open context, so instruction is load operand 0.00 and comment switch 1. Alright, step number 1. So moving downward, step number 1. Since it is normally close contact, so the instruction is load not operands and comment. Right, moving to the right, so the second step is N. Since it is in series connection, this one is parallel. Okay, and 0.02 switch 3. Alright, between this and this, first this one and this one, we must lock this. So step number 3 for this, it is all load because this is in parallel connection, so no operand and no comment. Alright, okay, sorry. Okay. Alright, so step number 4, as usual, output operand 0.00 and comment. Alright, okay, that's all.
At the end of the projects, I can conclude that we are able to use CX programmer software to program, testing and troubleshooting the error in PLC programming and engineering problem. From the activity that we have been done in this whole semester of this subject, we can conclude that we have achieved the second objective of this video, which is analyze PLC programming using various process description in order to operate an automation system for a variety of applications.
In conclusion, student able to assess student knowledge in the programmer logic controller, which is PLC, subject in order to be able to give a good and accurate description, which is summary from whole semester in this video.
Alright, can I conclude is by doing this project, students are able to give their opinion on the most efficient ways of learning by teaching the most difficult topic in PLC.